In this video, we're going to talk about completing the square. And this is still along the goal of solving quadratic equations. And this is one of two videos, so we're going to have two videos on completing the square. Let's talk about the goal of learning completing the square. Now, still under the idea that we're solving equations that are quadratic, we have seen how to solve equations where the left-hand side is a perfect square. For example, x plus some quantity squared equals a number. We've learned how to use the square root principle to rewrite this and get the solutions. Or, for example, when the left-hand side is x minus some number squared equals a number. Or the simpler way of x squared equals some number or something like that. Our goal is to be able to transform any quadratic equation to make it look like this. For example, if I have an equation like x squared plus 4x is equal to negative 2, I want to know how to use addition principle of equality to transform this into an equation that looks like a perfect square on the left side and a number on the right side. Because once I do that, again, I can use the square root principle. Or an equation that looks like this, x squared minus 6x plus 3 equals 0. Now notice in both of these cases, we can't factor the quadratic equation. And so we can't use the zero product property. And so it's necessary for us to learn how to change the form of these equations to look like perfect square on the left and a number on the right. And now I'm going to show you how to do this. The idea is, so on the one hand, on this left side here, we have x squared plus some number times x equals c. And here we're using the addition principle of equality to add a quantity to both sides. And since we're adding the same quantity, this is equivalent. Okay? But the nice thing is, when we do this, the left-hand side actually turns out to be a perfect square binomial. So the left-hand side, once we add this quantity, ends up being x plus b over 2 all squared equals some number. Okay. And so our goal is to identify this number to add on both sides of the equation, because then we're guaranteed that the left-hand side will be a perfect square. And the same idea works even if we have x squared minus some quantity times x. Okay? So again, we add this quantity to both sides, and then the left-hand side ends up being the difference binomial squared equals some number. Okay? So either way, we have a perfect square on the left, and we have a number on the right. Okay? But in both cases, let's kind of see if we can analyze this number. So this b here is the coefficient of x, and what we're doing is we're taking half of that coefficient and we're adding the square of that to both sides. Okay? So technically what we're doing here is adding half the coefficient, which is minus b in this case, but of course squaring that does not matter if we write plus or minus inside the parentheses. Okay, so let's take this away and let's actually see if we could work out an example. Okay, so we'll take the first example we wrote over there, and we'll see how to use completing the square to solve it. So this one says we have x squared plus 4x is equal to negative 2. So it kind of looks like this form over here, where the left side is exactly the same, where b is 4, and the right side is a number, or negative 2. Okay, so the number we want to add to both sides here is b over 2, which is of course 2, and the square of that. So this is the number we're going to add to both sides. Okay, so the first step is to say, okay, I have x squared plus 4x is equal to negative 2, and I'm going to add 2 squared to both sides. Okay, so that takes care of the correct number to add to both sides, and that's legal. Now the left-hand side, we know, is going to turn into a perfect square, like this. So the left-hand side will factor into x plus b over 2, which in this case is 2, squared equals, and here we could work out the math. This is 4 plus -2 is just 2. And now we have a perfect square on the left side and a number on the right side, and so now we could use the square root principle. And what does the square root principle say? Square root principle says that if we have a perfect square on the left and a number on the right, so here we have x plus 2 is equal to plus or minus the square root of the right-hand side. So we could perhaps subtract 2 on both sides, isolate x, so here we can subtract 2 on both sides, and we end up with x equals -2 plus or minus the square root of 2. And of course, those are the two numbers that land in my solution set. -2 minus square root of 2, comma, -2 plus the square root of 2. Also, those are the two numbers that live on the number line to identify these solutions. So -2 minus square root of 2 is somewhere here on the left of -2 plus square root of 2. Okay. Great, so the idea is that the process of adding this special number on both sides of the equation and showing that that actually makes the left-hand side factor into a perfect square, it's this process that we call completing the square. Let's take a look at another example. In this example, we have a quadratic equation that's slightly different, because on the left-hand side we have a trinomial, and we have this extra constant term that we're going to start by getting rid of because we want to use this idea here where left-hand side doesn't have a constant term. Okay, so let's actually subtract 3 from both sides here. Okay, and let's see that on the left side that leaves us with x squared minus 6x equals -3. So now we have an equation that looks like what we want it to, so we can go ahead and figure out this special number to add to both sides. Okay, so here in our work, when we're comparing this, we have minus b is the same as -6. So here what we have is b is actually 6. And so half of b is 3, and of course the square of that is 3 squared, which is 9, but we'll just write 3 squared right now. So what do we have here? On the left, we're going to add this special number so that we have x squared minus 6x plus 3 squared equals -3 plus 3 squared. Okay, so this number that we've added to both sides is the half of b all squared number, which we have here. Okay, and so we know that this turns it into a perfect square on the left. So the left-hand side factors into x minus half of b. Right? Be careful. Notice that we have a minus here. So x minus half of b, and of course half of b is 3. So that's that, squared equals, and if we work out the arithmetic here, that's 9. 9 plus -3 is 6. So now I have a perfect square on the left-hand side, and I have a number on the right-hand side, and now I can use the square root principle. Okay, so let's write that down. So now use the square root principle. Okay, so the square root principle says, okay, this is the equivalent to x minus 3 equals plus or minus the square root of 6. Okay, so and of course, isolate x by adding 3 to both sides, which gives x equals 3 plus or minus the square root of 6. Okay, and therefore the two numbers that live in my solution set are 3 minus square root of 6, comma 3 plus square root of 6. Okay, And to graph these solutions on a number line, well, which one's smaller? 3 minus square root of 6 is smaller than 3 plus square root of 6. So here, first number we're going to put is 3 minus square root of 6 and mark that in. And the one on the right side, right of that, is 3 plus square root of 6. Okay. Now in the next video, we're going to use the same ideas, but we're going to solve equations, quadratic equations that are slightly more complicated, not too much, but the basic idea is going to be the same.